Ciao friends and welcome to a new video from SQL BI. In this video, I want to show you how to compute a rolling average considering only working days. We have already created videos and articles about how to compute moving averages. They are not hard to compute because you can rely on DAX predefined functions like dates in period to compute the set of dates that needs to be considered for the rolling average. But if you want to add further conditions, so you want a rolling average over the last 30 working days, then the predefined functions do no longer work. You will need to author everything by yourself. And so the code becomes much more interesting to author, because not only we will need to find those working days, but we will also need to solve several small details in the process of writing the code. I'm going to show you the full process starting from the beginning, because the code is quite intricate, so at the end we will write a lot of DAX code. But hopefully, starting from the beginning, it will be easier to understand the complete flow and then adapt the code to your specific model. And we will see two variations of the same code. One that relies on a calculated column in the date table to compute the working day number. It works, it's faster, but it has the limitation that you need to create a calculated column. And if, for example, you are working with a live connection, then creating a calculated column is not an option. So we will adapt the code to work just in a measure. But let's start from the very beginning with some examples. This is our regular Contoso model. I just removed some columns to show you how to compute them using DAX. And I have this report that is showing by date, the day of the week, and the sales amount. We have sales on Saturday and Sundays, but what I want to do is compute the sales amount, the average sales amount day by day, considering a moving average of the last 30 working days. So I'm not interested in computing the last 30 days, but the last 30 working days. And the first ingredient that we need in order to decide whether a day is a working day or not is a column in the date table that tells us whether a day is a working day or not. The column needs to be computed somewhere, because it's not only that you need to get rid of Saturdays and Sundays, but you also need to get rid of any holiday. And the holiday depends on a lot of factors, on the country, on the region, on the year, on the business, on a lot of different details that we are not interested in worrying about using DAX. So we assume that you have in your date table a column, working days, that tells you whether a day is a working day or not. So, for example, here we have a Sunday, and Sunday is not a working day. Then we have Saturdays and Sunday that are again not working days, and the same here, Saturdays and Sunday that are not working days. So we are going to use the working day column in order to decide whether a day is a working day or not. Now let's focus on the problem by looking again at the content of the table. What we need to do is being able on any individual date, for example, well, not on this Sunday, but on this Thursday, what if I want to go back 5 or 10 working days? Well, I need to start counting back. So from here, I need to start counting 1, then 2, 3. I do not need to take into account Sunday and Saturday, so I go on 4, 5, 6. The six working days before that day was this Wednesday. And this counting operation needs to get rid of Saturdays and Sundays. The easiest way to accomplish this is to add a new calculated column to the date table. What I want is the working day number. The working day number is just a number that increments of 1 every working day and stops incrementing during Saturdays and Sunday. So that when I know the working day number of a date, I can just subtract the number of working days that I want to go back, and I will be able to compute the date that I want to use as the starting point for my moving average. Let's do that together. An easy way of creating this calculated column is to rely on the rankx function. So we can create a new calculated column, and with a larger font, we call it working day number. We can use rankx to perform a ranking over date based on date. If I compute a ranking this way, I obtain a number that ranks the dates from the smallest to the largest one. Actually, it's going to work the opposite way. You see that it starts from the very beginning with a large number and then it decreases by 1, because I want to do the ranking by date, but I want the order to be ascending. By default, it's descending. And now I have my working day number. That is not yet the working day number because it grows also on Saturdays and Sundays. You see that on Saturdays and Sunday it goes 7, 8, and what I want to do is stop counting 7 and 8. So the technique to do that is just to get rid of non-working days. I do not perform the ranking on date, but I filter the date where date is working day. By using date working day, I have only the dates that are working days, and my number will stop growing on Saturdays and Sundays. Let's hit enter to see the result. And now you see that here I have Saturdays and Sunday that repeat the value 5, and then it goes on increasing on Monday, Tuesday, and Wednesday. I still have a small problem here. You see that the value of Saturday and Sunday is not the same value as Friday. What I want is to stop counting. I want 4, 4, and then continue increasing with 5. So what I need to do is just subtract 1 whenever the current date is not a working day. So I can just subtract 1 using if date working day, I subtract 1, otherwise I subtract 0. By using this if statement, now I have my number that, let me see, it's not working. Why? If oh yes, if not, date is working day. 1, otherwise 0. Okay. So I have here Saturdays and Sunday that repeat the number 4, that is the number of Friday. And the same happens here. I have Friday, Saturday, and Sunday that repeat the number Friday 9, and they repeat the number 9. This Monday is not a working day, so it's not increasing again. Despite working, this is using the if statement, and it would be better to avoid using if statements in a calculated column, but in general, reducing the number of if statements increases the speed of your code. So I can rely on a different technique, because I know that if not day working day is true, then it is considered as 1. In DAX, 1 is true and 0 is false. So instead of using if, I can just subtract not working day. And the code results are identical, so I still have a value that repeats the value of Friday to Saturdays and Sunday, both here and here, but it is slightly better optimized. And this is going to be important not now, because in a calculated column it's not so relevant to have optimized code, but it will be later, because when we do everything with a measure, having code that runs faster is better, because that code will be executed all the time. Now that I have my working day number, I can easily compute from the current date the previous working date. The date to be used as the beginning of the set of dates that I want to use. Because if I know, for example, that the current working day number is 7 and I want to go back 5 working days, I need to go to the working day number 2, which happens to be this Wednesday. So by simply doing a subtraction, I can discover the working day number of the date that I need to use as the lower part of my rolling average. And it's now time to start writing the code of our rolling average. Let's start writing the rolling let's go for a 30 working day average. Rolling third working day average. First of all, I need to find the upper boundary of the set of dates that I want to use as my filter. And the upper boundary is just the maximum working day. So I store in a variable the max working day, which is the max of date working day number. Return, and let's return the max working day, just to check that we have a good number. We place it here, and we have the rolling, it's not a rolling 30-day average, this is just the maximum working days, 96, 97, 97, 97, because it's Saturday and Sunday, and then 98, 99. Then I want to subtract 30 from this value, so let's create a new variable that is the number of days, 30. So we retrieve the minimum working day, which is the max working days minus the number of days. Number of days. Let's check that we have a good number also here. And we do. This is the current maximum working days minus the minimum working day. The next step is to find the set of dates that I want to use. And I can just use these two values, min and max working day, to find the set of dates. So I can create a new variable, dates to use, and I can filter all day date, where, well, let's go for a table filter. Date is a small table. All date where date working day number is greater or equal than the minimum working day, and at the same time the date working day number is less or equal than the maximum working day. This table contains all the dates that happen to be between the two boundaries, and the last step is just to compute the sales amount in this period and divide it by the number of days, 30 days. So I can create the result by just dividing. Well, I can do just calculate sales amount using the dates to use. Let's make it a bit shorter. Calculate sales amount in the dates to use, and then I divide this value by the number of days. So to compute the average sales by the number of days. And then I just return, this time, the result. Let me decrease the font a bit because the code is going to be much longer than this. So now this is the rolling 30-day average, which is not yet perfect. It's gonna work, it produces a number, but this number is not exactly what I want. Let's format it as a decimal number. And with 2 decimal places and with commas, because I want to compare it with the values. So this is the sales amount, and this is the rolling 30-day average that after 30 days will start to be a better number. It's working, but you see that it's not perfect. Look at the value between Friday, Saturday, and Sunday here. We have the value of the sales amount, the rolling 30-day average, but the same value is repeated here, here, and here for Friday, Saturday, and Sunday. So I do not expect these numbers to be identical. I would like them to be different. And the reason is I don't want to count the sales of Saturday on Friday, because Friday is a working day, Saturday is not a working day, but we still have sales. It cannot be that the value of Friday, Saturday and Sunday are the same. Saturday and Sunday, it makes sense that they are the same because we do not have sales in Sunday, but Friday and Saturday, they should be different. By only considering the working day number, we are adding the sales of Saturday also on Fridays. What we need to do is change it a bit. We cannot just use a filter for the working day number. The working day number needs to be greater than the minimum working day, but the working day number needs to be less than the max working day, and the date needs to be less than the max date. So we need a new variable to compute the max date. Let's call it max date, which is just the max of date. And we change this condition to say I want the date to be less or equal than the max date. By doing this small change, I now have a better picture. You see that the value on Friday is a value, the value on Saturday takes into account another value, and the value on Sunday is the same as Saturday. So it's going to be a bit better than before. Still, this calculation has a small glitch, because being a rolling average, it will continue computing values also at the end of the period and slowly decrease. It's not evident if we use just the matrix, but it becomes much more evident if we use a line chart. So let me move it here. Let's get rid of the day of the week and transform that into a line chart. You see the effect. The rolling average is computing a good average and it's showing a behavior over 30 days in a better way. But we do have here, at the end of the period, we no longer have sales, but the rolling average is slowly decreasing. That is an effect that I want to avoid. So I want to blank the measure after the last date with sales. That requires changing again my rolling 30-day average a bit. I want to compute the max dates ever. Let's do that here. Let's call it max date ever, which is calculated the max of date, removing any filter from the model. So that is the last date ever in the, not max date, max sales order date, removing any filter. And once I have the max date ever, I just check if the max date is less or equal than the max date ever, I return the result. Otherwise, I blank out the measure. So to avoid having the tail of decreasing values. And by doing that, you see that now my chart stops when there are no sales. So this code is now working better. It's computing the rolling average over 30 days, taking into account that you might have sales also in non-working days. That might be wrong, but the database we have works like this, and we want to take into account also this aspect. And we got rid of the tail of the rolling average after the last date. The problem with this code is that it needs a calculated column. So creating a calculated column is not a problem if you are working in import mode with Vertipack. But if you are about to create the same calculation in a live connection, then calculated columns are not an option. And what we can do is create the same algorithm, but this time in a measure without relying on a calculated column. That requires us to use add columns to create the calculated column as a temporary calculated column in the measure, and then perform the entire calculation using the temporary calculated column instead of using the calculated column inside the model. So it's going to become a bit more tricky because we need to change a couple of lines of code and add a temporary table to our measure. Let's do that together. The code is very close to the rolling 30-day average, but we will need to change this part because the maximum working day cannot rely on the working day number. And the same will happen here. We will need to create a temporary table for the working day number, and we will need a table containing the working day number computed on the fly. So let's start by copying the code and create a new measure that we call rolling 30 working days live. Right now it's the very same as the previous measure, as a decimal number. We need a temporary table that has the same code as our calculated column. So I copy the code of the calculated column, and then in my rolling 30-day average, I create a new variable dates that contains basically a copy of the date table, but this time with the new column. So we use add columns over all date, and we add a new column that we call working day. Let's use working day number. And here I place the same code as before, that I will need to format a bit. Rank X over filter, ascending, rank X. Okay, now I have a dates table that is not working because I'm referencing also the working day, so I need to add this date working day. Now I have my dates table that contains the same structure of the date table. Actually, it contains only the date and the working day column, and then it performs the ranking. Number of days is fine. Max working day can no longer be computed as the maximum of working day number because we cannot rely on the working day number. So what we can do is compute before the max date, and the max working day becomes a max X over dates of my working day number column, not over all dates, but a filter of dates where the date is less or equal than the max date. And we also need to format this. Max X, this need to go down. Okay, so now I have the number of days, I have the max date, the maximum working day, everything is computed on top of the dates table, so I'm no longer relying on the working day number column. Then the minimum working day is still correct, the max date ever is still correct, and dates to use is not going to filter all date, but it filters dates, where the working day number column, my temporary column, is greater than the minimum working day, and the date is less than the max date. This dates to use contains a table that has the date column inside, so I can use this as a filter in Calculate, and this is just going to work. I just need to get rid of any filter on the date in case I didn't mark it as a date table. And that's it. Now, this code no longer relies on the working day number, and if I did everything correctly, that should produce the same number as the other measure. Let's check it. It's already a decimal number. We can go here, take the rolling 30-day average live, and you see it's a bit slower than the previous one because it's not relying on a calculated column, but it produces the same number, and it works just by using temporary calculation. So it does not rely, let me see, there's quite a lot of code, but it does not rely on any calculated column. Quite a complex formula, but having followed from the beginning, you should be able to understand it and maybe adapt it to your specific needs. As you have seen, once you learn DAX and once you get used to use tables and do calculations, solving a problem like the rolling average over a given number of days considering only working days, requires some effort, but is a calculation that is not that complex. Yes, at the end the code was quite complex, but having seen it step by step from the very beginning, you can appreciate that by using DAX you combine simple functions to create complex calculations. And the version with the calculated column is going to be fast and efficient, but requires you to create a calculated column. If that is not an option, you can go for the measure version that works nicely in a measure. It's going to be a bit slower, not that slow, because it only needs to compute the dates table that has the cardinality of dates, and date is not quite often a very large table. Once you have a small number of years in the date table, the table is quite small, and the calculation can happen on the fly quite easily. If you have a lot of dates, then it's going to be slow, and for sure the calculated column version works much better. Enjoy DAX!